Hello, friends. This is Jim here with Science Talk, and I wanted to do this follow-up video to the video I just posted, talking about uh, the ocean stabilizing, how that is not a very good thing. And in that prior video that I featured, I discussed some of the comments of Dr. Michael Mann. Now, I'm going to be right up front and say that I respect the man. He has done excellent science. But his recent comments on several fronts have, let's just say, left me befuddled. And I want to address those comments in this video. Let's start with his contention that if emissions were to go to zero, that the planet's climate will stabilize at no more than a 2°C increase from pre-industrial times. I disagree. He cited that there's been some recent research that apparently the modeling shows this to be the case. I pretty much go through the literature and I have not really seen any such papers. I could be not looking in the correct places, but I have not seen any. The papers that I'm seeing, the research that I'm seeing, which are ones I share with you, all indicating basically a runaway system. That the warming is just going to continue and continue and continue. Now, this is surprising to me because, Dr. Mann is an atmospheric scientist. He knows and understands physics and mathematics. He dismissed thermal inertia. He's saying, well, thermal inertia will just, quit. No. There's a lot of thermal inertia in the system that warming will continue. And I'll go through some of those aspects of the thermal inertia. So when he says those comments that, everything will be fine, only be 2°C, that's not being realistic, I'm sorry to say. Even a 2°C increase will cause havoc on the planet. I mean, we're already seeing it now. We're about, 1.4, 1.5 C? I mean, fires, floods, droughts, intense storms, you name it. We're seeing it. We're living it now. So what about this thermal inertia aspect? Well, first of all, he makes the erroneous assumption that the oceans will continue to absorb the heat, and that if we stop emissions, we just absorb all that extra heat, it's in the ocean, we're good. No. The oceans, via the thermohaline circulation, sequesters carbon dioxide, but also heat. It takes it from the surface waters, moves on down to depth, sequesters it out of the immediate ocean atmospheric coupled system. If you have stabilized ocean, in other words, oceans are stratified where you don't have thermohaline circulation, you don't have mixing between the layers, that heat is going to stay trapped in the upper layers, along with the CO2, which will increase the acidification of the upper layers. The oceans are warming up. We have the data for that. As I've stressed many times, solubility of gases decreases with an increase in water temperature. Waters can only hold so much, and they have held, right now, they are storing something on the order of about 2 times 10 to the 23 joules of energy, which is a great majority of how much energy we have put into the system since we started burning fossil fuels. As the waters continue to warm up, the solubility gases will decrease, and the oceans will not be able to absorb any more CO2. So now the CO2 that was going to be assumed to be absorbed by the ocean now stays in the atmosphere. And as the oceans keep warming, some of that gas, some of that CO2 will outgas back into the atmosphere, further increasing the CO2 levels. So that's an erroneous assumption, and it's basically not quite taken into account the fluid dynamics of the oceans. So there's that issue. The other issue, another issue, is that we've already kick-started so many feedback loops. You know, the ice melting, the permafrost thawing, that those, especially with the ice melting, but you got the permafrost thawing, all those gases are going to be kept dumping into the atmosphere. The methane, the nitrous oxide, in addition to the CO2. That's going to further exacerbate matters. We're going to further increase the carbon equivalent levels, which is about 560 right now, so thereabouts, which will, in a positive feedback loop, make things worse and worse. The carbon is here to stay. It's not going to be drawn out of the atmosphere. It's not going to be drawn down anytime soon. And also, the very assumption that we can get to zero emissions is erroneous. Even if we do stop burning fossil fuels, we've got, for example, methane leaking out of capped wellheads. But all the positive feedback loops I just mentioned, they're still going to continue to introduce greenhouse gases into the atmosphere. But it's also not a realistic assumption, because we're still going to need to extract fossil fuels. I'll give you an example. The biggest, one of the biggest, not the biggest, but one of the biggest users of petroleum products is the medical profession. Think about the IV bags, the plastic tubing that comes from the IV bag to the plastic valve that controls the flow of whatever's in the bag that goes into your vein. The only thing that's non-plastic is the needle, which is metal. That's plastic. Those are all plastic products. So we're going to have to keep extracting petroleum products to make those plastics for the medical profession. What's the alternative? Glass bottles? Okay. You have to sterilize the glass bottles. And glass bottles, you're going to have what? Rubber tubing? Well, okay, rubber, you still have to go to the rubber trees and so on. But what are you going to have to do with the glass bottles and the rubber tubing? You have to sterilize them. You have to put them in an autoclave. Autoclave uses energy. So, and when you think about all the hospitals around the world, that is a significant amount of energy needed to sterilize bottles. So getting to zero emissions is not realistic. There's always going to be some fossil fuel that needs to be extracted. The other thing that I found annoying was when he refers to those of us who say that we're looking at 5 to 7 to 9 to 10 C increase by 2100, calling us doomers, that, oh, it's too late because of, he dismisses now thermal inertia, which should not be dismissed. So it's now too late. We can't do anything about it. We're all fucked. Well, we're being realistic. When you have numerous models, all now, I'm seeing numerous models now assuming exponentiation, and they're all showing a minimum of 5C by 2100, but now I'm seeing 7. Some of the higher ends are 9, 10, even 11C by 2100. Why the range there? Because of the water vapor parameter. Water vapor is very, very difficult to model in climate models. It's a double-edged sword. The bottom of clouds traps heat. The top of the cloud reflects heat, albedo. Right? So how do you treat that in the heat equations? It's very difficult. That's the old joke. If you ever looked at the original Star Trek series episode, the Enterprise approaches a planet, and there's not a cloud that you can see on the planet, from space, because clouds are difficult to model. Kind of an old physics joke, but yeah, clouds are difficult to model. So that's why we see the range from like 7 to 9 to 10, what have you, or 5. But the point is, it's going to be exponentiating. Excuse me. And there are some folks who think we might see a 10C increase within 1 to 2 decades, which would basically cause like 99% extinction on the surface. There are, I remember doing a video some time ago where I discussed the results of a think tank out of Australia that they assess, based on what's going on, that by 2050, human civilization will cease to exist. Now, it should also be noted that many ecologists consider that an increase of 4C will cause humans to go extinct. So if we're talking 5 to 7 to 9 to 10C by 2100, and then this Australian think tank says 2050 would be no human civilization, they're all kind of in agreement that humans could very well be extinct by the end of this century, in all seriousness. So it is, I don't understand why Dr. Mann said such comments. You can't argue with physics, and the physics telling us a completely different thing. And the carbon is there to stay. It just is. It takes a very, very, very long time to draw down the CO2 from the atmosphere. Several millennia at least, depending on the level. Sometimes millions of years. Look at the video I did about barreling towards hothouse Earth with that graphic I put up there. Look how long it took to draw down the CO2 levels from the PETM down to recent times with the ice ages. It was basically 50 million years. So I disagree with Dr. Mann. We could stop emissions, and temperatures are still going to increase for all the reasons I outlined. And don't forget, we did an experiment last year. When the first COVID lockdown was implemented, airplanes were grounded, people stayed at home, they weren't driving around as much, with all the Zoom stuff from home, what have you. And yes, there was a very measurable decrease in greenhouse gas emissions. It was measured. It was something like a 7% decrease. But guess what temperatures continue to do? They continue to increase. I think the level they measure is something like 0.1 C per year. That means 10 years, okay, that's another degree C with that reduced amount. But you know what? Planes are flying again. People are driving around again. It's going right back up. And so we're going to probably resume the warming levels before the COVID lockdowns. And as we're now finding out, and thanks to the excellent work by Zach Labe, It's just each year it keeps being ranked in the top 5 warmest. But basically, when you have 5 of the warmest years occurring in the last 6, 7 years or so, that's a trend. It's like, as Brian Brettschneider would say, it's as if though something has changed. Yes. We've now gone past that threshold where we're really going to start rapidly exponentiating matters. And we're seeing that now. Think, how things were 20 years ago. Think how they were 10 years ago and how things have changed. Think how much things have changed in the last 2 years. And the other thing that's going to happen is, as we get into the BOEs, the Blue Ocean events, it's game over. As the Finnish Prime Minister told Trump, if you lose the Arctic sea ice, you lose the planet. That's not hyperbole. He's correct. Because now, instead of reflecting all that heat, the ocean is going to be absorbing all that heat. And that's why we're seeing ice forming later in the year and melting early in the year, because there's less ice, so the oceans are absorbing the heat. So that's further energy that has to be released in cooling down the water, plus cooling it down past 0°C because of freezing point depression, so that by the time sufficient heat energy is lost so that the ice can start forming, well, it's later in the year, doesn't get as thick as it used to be. So we're also losing the multi-year sea ice. And by the way, multi-year sea ice is really very opaque, and it's the multi-year sea ice that reflects a great amount of the albedo back into space. If you have a first-year sea ice, it's still kind of translucent. So the albedo is lower, and there will be some sunlight energy going through the ice into the water. That's another thing to keep in mind. So you're throwing all this heat energy into the Arctic Ocean, and that's just going to warm things up massively. And right now, and there's always a lag because of the specific heat aspect of water. There's always a lag from the heat energy and then when it be manifested. So you have the ocean full of this latent heat energy. It's going to take a very, very long time for all that heat energy to dissipate into the atmosphere. And as it does, it keeps the atmosphere warm. I think that's something else that Dr. Mann forgets about. If you were to look at some of the videos I made when I first started this channel some 2 years ago, I posted some videos saying that global warming could lead to an ice age because of the slowing down of AMOC and the shutdown of AMOC. And that's because AMOC, which colloquially begins what's called a conveyor belt, is a heat distribution mechanism for the planet. And when that shuts down, the planet tips into an ice age. We have data indicating that. So when I was making those assessments, I was basically looking at the data. I don't think that anymore. Because there's so much heat energy in the water and in the system, that even if AMOC shuts down, that heat is still going to be dumping itself back into the atmosphere, forestalling any start of an ice age for at least one, if not several millennia, even with the thermohaline shut down. But here's the other thing, and I've said this in recent videos. Phytoplankton supply 55 to 80% of the atmospheric oxygen. Stratified oceans, without mixing, the phytos use up the nutrients, they die. Then the food web system dies. And then atmospheric oxygen levels start declining. Oh, did I mention that there's been teams of atmospheric scientists who are already measuring a decrease in atmospheric oxygen levels? Because the oceans are dying. Productivity in the oceans is down. That's another reason why humans will probably be on the way out the door. So if you see people saying that, well, if you stop emissions, we can stabilize the climate. Well, you're not, first of all, it's not stabilized, but you can stop the warming at no more than 2C, and everything will be honky-dory. They're wrong, and they are neglecting thermal inertia. They're neglecting the role of the oceans, and they're forgetting about specific heat, latent heat energy, and so forth. And when they start calling us doomers, we should basically have a retort that this is realism. This is reality. This is what's going on. So when I recorded that video that this is based an addendum to, Dr. Mann had not yet made those comments, and I felt it necessary to make this video to address those comments. So there you have it, and thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.